Good afternoon and welcome back to Stream 1 at DSC MENA 2025. I'm AbdElRhman ElMoghazy, your host for today, and we are continuing our sessions with AbdElRhman ElMoghazy, data scientist at Henkel. We walk us through how to build your very first Retrieval-Augmented Generation (RAG) system using Llama 3.1, from setting up your dataset to prompt engineering and evaluation. Now you can start, ANG Abdurrahman.
Thank you, Yusuf. So first, I'd like to know how many people know about the concept of RAG at the beginning. So I'll send you a poll, and I'll be waiting for your answer. So that we can actually start the session, okay? So yeah, if you could actually take this poll, then we can start the session. Oh, so say yes or no, but there is a third option, just you can ignore it, okay? Okay, sounds good. Sounds good. So this will be an okay, thank you. So this will be an introductory workshop. We will go through some code for a basic RAG, and then we will go through the evaluation, how we can evaluate it using LLM as a judge specifically, because there are different methods of evaluation for RAGs. But for now, what I would like to say is that the workshop is going to be very interactive. So I'm going to ask a lot of questions, and based on those questions, we are going to adjust, the level of the session itself, and also adjust the information that I'm going to say. Okay. And with that, I think we can start. Oh yeah, and also if you have any question, you can just write it in the chat, or you can raise your hand. And I'm not very sure how the raise hand works here, but you can raise your hand and um, unmute yourself and ask the question. Okay. So first, before diving deeper into what RAG is, let's actually, have a little bit of foundation about what a large language model is, or before even defining a large language model, what a language model is. So let's first start with a very basic question so that I understand better your backgrounds as well. So if you could, no, if anyone could raise hand and define what do you think a language model is? Not a large language model, but a language model. Okay. Or you can also write in the chat. Or what do you know about the concept of language models in general? Okay. Anyone would like to answer this? Okay. So maybe we will adjust how the session goes. Yusuf, I still don't see the list of participants, so if you can help me with that. Okay, no problem, no problem. So in general, let's see what a language model is. A language model is basically, well, it has been in natural language processing for many years now. A language model is basically a model that is predicting the next word. Okay. So this is what a language model is, and it has been there before even large language models and before ChatGPT and so on. So what is large language model? Large language model, from its name, it is a neural network that is actually trained on massive amount of data. Okay, um, and it is not just large because of the number of the amount of data it is trained on, but it is also large because of the number of parameters for that neural network or for that model. So it is a language model, which means that the main task it tries to do is to predict the next word. Okay, given a sequence of words, predict the next word. For example, given while, you should predict that the next word is fine tuning. Given while fine tuning, you predict the next word is can. Given while fine tuning can significantly, you predict improve. Okay, this is how large language models work, or this is how they are trained. They are trained on unlabeled data, and this is what we have here in this graph. So let me annotate it a little bit. So basically, here it starts with raw data. Okay, this is unlabeled data, and this is a very important concept because large language models are self-supervised. You provide it with unlabeled data, and then basically the data nowadays are kind of most of the public data on the internet. Okay, this is how they train the large language models. And then after you go ahead with the training using unlabeled data as a self-supervised, then this process is called pre-training. Okay, you get a foundational model, which we basically called a pre-trained LLM. Okay, so a pre-trained LLM is a foundational model in the sense that it is trained on everything on the internet, so it will hallucinate, and we know that it will hallucinate. Um, but then it is not suitable for every use case. It's suitable for some use cases, for example, direct use of ChatGPT, direct use of DeepSeek, and so on. So after pre-training the foundational model, you can use it directly through ChatGPT. You can use it directly through DeepSeek. You can use it directly uh, through other providers like Sonnet and so on. Okay, and the idea is that those are typically used for general information. You cannot really use them for tasks that needs accuracy, or for tasks that needs high precision the answers themselves. So for example, you cannot use it in certain domains that requires that the answers are actually accurate. Okay, now we need it to be more suitable for other tasks. For example, what if I wanted to be suitable to cluster if to classify if emails are spam or not? Okay, this is one of the of the use cases. We cannot use the foundational model directly, or it is not encouraged to use the foundational model directly. Of course, you can, but it is not encouraged because it is going to hallucinate. So what we want to do is that we want to provide it with labeled data to fine tune it. So first we use unlabeled data, then we fine tune it using labeled data, and this is the fine tuning of large language models. Okay, and we have two types of fine tuning. We have instruction fine tuning and we have classification fine tuning. For example, you give it a lot of emails, but then the data is not huge like the pre-training part. You are fine tuning, so they are not really huge amount of data, but they are sufficient for the model itself. Okay, so you give it a lot of emails and you give it the labels for the emails, whether they are spam or not. Okay, and this is how fine tuning actually works. For instruction fine tuning, for example, you can give it some instructions to translate, for example, a query, and then you give it the answer pair, which is the translated query, and so on. Okay, so this is how large language models work. Now, I need you to to think with me what kind of problems might happen with a language model if you wanted to use it, for example, on your private company data. What do you think might be the bottleneck here? What might be the problem? I want to use a language model, a large language model, to, for example, answer my questions based on my company data, a private data. What do you think might be the problem here? Can someone answer this question? Oh, you can write it in the chat directly. Oh, yeah. Yeah, exactly. The knowledge base and the data leakage. Thank you, Ahmed and Muhammad. So, exactly. This is exactly the problem. So, the problem is that the data is private in this case. And with private data comes the the risk of leakage of this data to the public. Because, for example, if you use ChatGPT directly on your data, then there is no guarantee that your data is not going to be used in the training of ChatGPT itself. And then this data might be leaked to the public, okay? And to be able to use this, now we are going through the concept of RAGs. This is why actually we are using RAGs, okay? So because of two things. One of them, because we need to use it with custom data, data that is not public and that the model wasn't trained on. This is one thing. So, and the other thing is because of the criticality of the data itself, because it is a private data. Okay. Now, if the data is not private, then you might think that, okay, so I'm going to do fine tuning to the model. I'm going to add more data to it so that the model understands what I'm talking about. But the problem with this approach is that um, yes, you can add more data, but then you are going to fine tune it further and add more data and add more data and add more data for multiple tasks. Whenever your knowledge base increases actually in size or anything else you want the model to be trained on, okay? Because this is not going to answer any question based on data that it wasn't trained on. So you need to train it periodically on any new data that comes to your knowledge base, okay? And this is not what we want to do. We want to use a cheap solution that actually uses the capabilities of large language models, but on your private data. And this is where actually RAG comes. Okay. So, so I see a question in the chat. What about the option in ChatGPT to not use your data for training? How can we be sure that they are not using our data regardless? Okay, so that's a very good question. So I don't believe there is a guarantee. I mean, if you are working in a company, I don't believe there is a guarantee unless there is some kind of a contract, okay? So if they say that they are not going to use the data, it's fine. And if your company trusts them well, then you can use it. But I mean, most of the companies now are trying to do some contracts with those either ChatGPT or other companies so that they can actually make sure that their data is not going to be used, and there is a contract, a written contract that the data is not going to be used. For example, instead of using ChatGPT directly, some companies are resorting to using Azure OpenAI API so that you can actually use the capabilities of GPT models, but for example, GPT-4o, for example, but then there's a contract between your company and Azure that this is not going to be used in any training purpose, okay? So was that clear? Okay, sounds good. So now I want to go through what RAG is, okay? So basically, a RAG is a large language model. We are using the capabilities of large language models, the pre-trained large language models, I mean the foundational models, but we are not going to use it to infer the answer from its training data. We don't care about the training data. The training data might not be accurate, might hallucinate a little bit, and hallucinate is the technical word of getting wrong answers from large language model in a simplification, okay? So we don't want it to hallucinate. We don't want to use its knowledge base or the data it was trained on, right? We want to use our own data with the capabilities of large language models, with the reasoning capabilities of large language models. And here comes the RAG part, okay? So let's just go through this part here and annotate it a little bit. So the RAG consists of two main parts, the retrieval and the generation, okay? But there are two other components. the knowledge base and the query. Okay, so we have the query, the user query. For example, I want to query the knowledge base of which sports team won the World Cup in 2024, for example, or something like that. Okay, and I have the knowledge base about this. Or to be more specific, I want to query a company data that's working in car manufacturing, for example, about specific materials or specific components inside the catalog or the product catalog that we have in the company. Okay, this is one of the use cases that can be used with RAGs. So this will be the query or the question. What do I want to know? Okay, and then the other component is the knowledge base. This is the thing that I want to query. I want the large language model to get its information from. Okay. So, and then we have the retrieval and the generation. Now, those components with RAGs are very important. Each one of them is very important. They might seem very simple, but there are also a huge margin of improvement when it comes to each component. We can improve it here in the link between the retrieval and the generation. We can improve it here in the embedding part of the query and the embedding part of the knowledge base, and we can improve it in the indexing part. Okay, we will go through this in a minute. Okay, so now the idea is that if we want to really use our data from our knowledge base, then we need a way to understand which part of the knowledge base is related to my question, right? For example, I want to ask a question which, for example, team won World Cup 2024, for example. Okay. So for this question, I want to check the similarity between it and different chunks inside the different paragraphs inside the documents that I have. Okay, for example, they are PDF documents. Okay. So first thing, you parse the documents into, let's say now, chunks. We can just ignore the word chunks for now. We are going to go through this in a minute. But then after going through the chunks, we want to check which one is more similar to my question here. And then we want to, for example, this one was similar to the question, I mean, related to the question, and this one was related to the question. Then I'm going to make a prompt for my large language model and adding to it chunk 1 and chunk 3 and ask the model to get the answer from those related chunks, chunk 1 and chunk 3. We are going to this, we are going through this in a minute, so don't worry about it now. But then we are going to see it in code directly. Okay. Now the model is going to have the related chunks and the large language model, for example, for example, GPT-4o, for example, or Llama 3, and then it is going to use this for generation part. Okay. And this is why we call it grounded generation. It is generation, just that shouldn't be that shouldn't get any answer that is not inside the context, okay, or inside the related information that I got from my PDFs. Okay. Do you have any questions till now? Because we are going to go through the code now. Okay. Any question? If those concepts are actually clear, you can give a thumbs up so that I understand that everything is clear. Okay, sounds good. Sounds good. Now, let's go through the code, okay? Oh, yeah. Let's go through the benefits of RAGs first. So, a RAG is very important because it grounds the generation process. Now we are getting less hallucinations, okay? But is this actually the case that we are not getting any hallucination at all? Let me tell you one example that has been resonating in the field for a while now. So, for example, one of the companies, one of the air companies in Canada, it's called Air Canada, I think, or something like that. I don't remember the name exactly. one of the transportation companies, they had a chat model or that is based on RAGs, and the chat model actually, or the chatbot, was chatting with one of the customers, and and it gave it false information, and the false information says that she can get actually some discount, and then that wasn't actually the case. That wasn't accurate, and the website itself had information that in this specific case there are no discounts. Okay, so and there had been actually some legal actions and so on, and the company actually was demanded to give the discount to the customer. So it is not always accurate. This is what I mean. Um, we want to make it accurate, and to make it accurate, we want to utilize the optimization methods in different aspects of the RAGs, okay? In indexing, in context, in user query, and in generation, in the retrieval. All of those parts can actually use some optimization, and to do the optimizations, we need to understand how to evaluate the RAG first. So now we are going to implement a very simple RAG, and we are going to know how to evaluate it using one of the new methods that's called LLM as a judge, okay? So yeah. Yeah, now the benefits of RAGs again are that you don't need to train it uh, specifically like fine tuning or something like that. So it's less costly, and it reduces hallucination. And this is what we were talking about. Okay, now I'm going to copy some libraries and install some libraries here. We are going to talk about them in the cells below. Not here, I mean, in the cells where we are going to use them, but in general, we are going to use a library called Llama. Llama is actually a library that enables you to host a large language model on your computer, or in this case, I'm using it in my Colab environment, okay? So Llama can be integrated very easily with LangChain, for example. Um, and LangChain is one of the libraries that integrates, for example, parsers and a lot of capabilities that we need to use when we implement a large language model or a RAG. Okay. Um, so yeah, we are going to talk about them in details below. Okay. So first, we are going to download our libraries and import our models and so on. It's going to take a while. And now we will just specify for PyTorch that we want to use a GPU because the operations here are very costly. I don't encourage you to run it on your personal PC. You can try, but then it would take a lot of time for inference because large language models needs a lot of, they have billions of parameters, and I'm using one of the light models. I mean, 8 billion parameters only. But then if you use, for example, the 70 billion parameters and so on, then you are going to use a larger GPU, okay? And here we specify that we want to use some GPU. And if there is no GPU available, then use a CPU, but then it will take a lot of time. Now, the next step, yeah, this is still running. So the next step here is to use Llama, okay? And as I said before, so Llama is actually hosting the model itself on your device. And this is this part here. You install Llama first, and then you open Llama through the shell on your device, as if you are just using your shell on your computer and you are, opening Llama in the background, okay? Now you will be able to pull models through Llama, which is actually operational now in the background, and you can also query Llama, one of the models that you pulled, and so on. So Llama is now, it is the library itself, okay? Or it is the framework itself. What I need to use here, oh yeah, here we are going to explore which actually port we are listening to. I mean, which port Llama is listening to. It is not necessary, but I want to show it to you. Yeah, still installing the libraries here, so it's going to take a while. I'm going to explain just those operational topics here till it actually finish executing the above cell, okay? Now, after actually you manage to operate Llama, now I want to download the model from it. And to understand what downloading a model is, let me show you something. So this is the Llama library here, and those are the models in Llama library. Okay, so there are a lot of models. You can use DeepSeek, you can use Mistral, you can use 3.3, Llama 3.3, and so on. I used Llama 3.1, which is a light model, an 8B model, 8 billion parameters model, and but there are a lot of choices that you can actually choose from. There are Quinn, there are Lava, there are a lot of models, amazing models, I mean, that you can choose from. And you can actually search through the leaderboard and check which actually model is much stronger than the other and choose one of them. But yeah, in general, I just used Llama 3. Okay, Llama 3.1. And specifically, I'm using Llama 3.1 Instruct. Okay, there is a difference between Llama 3.1 and Llama 3.1 Instruct in the way it was trained. Okay, so Llama 3.1 Instruct is fine-tuned on instructions. And I believe that it might be more, I believe that might be better actually for question answering tasks, okay? So you can choose which model from Llama 3.1 to use from here. And yeah, now you can download the model directly through Llama. So Llama pull, and then the name of the models that you got from the list here, okay? Now that the model is actually downloaded, you can now yeah, you can actually use it directly. For example, let me show you how to use it in a second, but I'm going also to use Llama 3.3. I'm going to talk about this in the different part, in the evaluation part, and actually why to use it also. Now we download it as well, okay? So what is the main task here in this tutorial? The main task is that there is a course that is called Hugging Face NLP course, okay? This course. It contains videos, it contains text, but I'm not interested in videos right now. It is not a multimodal RAG. There is a multimodal RAG, definitely. You can implement it, and you can convert videos, for example, into you can transcribe the videos, and you can then take the text and do the RAG on the videos and also on the images and so on. But this is not the topic for today. We are using a very simple RAG. Okay. Now, what I wanted to do now is, given this course, I wanted the students to be able to chat with the course, to ask the course questions and get the answers from the course, and only from the course, not from any answer that was in the training data of the Llama model itself. Okay. Is it clear now what is the task? Oh, yeah, you can give me some thumbs up or something like that to understand if I need to go through the task again. Okay. Okay, sounds good. So now the course itself consists of different pages, as you can see. Each page of them contains some information and some coding and so on. I'll make a very simple scrapping code, but to understand how to actually get the content itself, let me press on inspect element. And as you can see here, this is the part that we want to get our data from. Okay, only this part. Now you can take the class name and put it inside our code, and our code uses actually Beautiful Soup. Beautiful Soup is one of the libraries that actually can parse HTML tags and so on. And now we want to specify the class that contains the information that we need. If we don't do this, then it is going to actually get all the information from the website, including the panel on the right, and the panel on the right kind of contains, the names of the questions, sorry, the names of the chapters, and the names of the chapters can actually be now will be in every page. So here in this page, you will have this panel. In this page, you'll have this panel. In this page, you'll have this panel. And then if you ask a question, for example, about transformers, then you will get it in every page, because transformers is now actually part of every page, okay? So we don't want to, oh yeah, there's a question. Yeah, you need me to repeat the part about the task. Okay. So the task again is to actually make a chatbot that can chat with this course, okay, content. I want students, for example, to be able to ask this course, I mean the chatbot, any question about this course, and the chatbot can answer it directly from the course or from the content, okay, from this course pages. And to do this, I need first to scrap the data from the course, okay? This is the first thing that we need to do. We need to scrap the data from the course. And to scrap the data from the course, I don't want this panel on the left actually to appear. And to do this, I'm going to do inspect element. After doing inspect element, I'm going to, select only the panel that I want that contains the main part of the text, which is this one. Okay, I think it is this one. Okay, let's do this again. Yeah, it is this one. So you take the name from here, the name of the class from here, and you put it here for Beautiful Soup to select. You want only to select the text in this class, okay, in HTML. Now, let's go through it in more details. The first thing I want to do is that I want to check actually how the course is structured. It's structured in this way. So chapter 1, page 1 is chapter 1, then /1, okay? Now chapter 1, page 2 is chapter 1/2. So the first thing to do is to actually loop through, I know that there are no more than 12 chapters. So I'm looping through every chapter, the 12 chapters, and I am adding the base URL, which is this one, Hugging Face Learn NLP course chapter, and then this is blank, and then slash, and this is blank. And we want to populate those blanks with actually the numbers, okay? So it is chapter 1, and then page 1 through 20, chapter 2, page 1 through 20, and so on. So it will be like that, okay? Let me take it here and run it. And then we now have courses that contains a list of chapter 0, page 0, chapter 1, page 0, chapter 2, page 0, and then chapter 0, page 1, chapter 1, page 1, chapter 2, page 1, so on, okay? This is what we want. Now, we understand that some of those pages are not there, are not available, and this is why, for example, there is no chapter 0, okay? So it will give a 404. So we will catch it later, but just for simplicity, we did it that way, okay? Now, here in the load page, it takes the URL that actually we got here in courses, and then it checks if the URL is 404 or 200. So if it is 200, then return the text. If it is not, then pass. I don't want a page that is actually giving me a 404, okay? Now, we go through each URL inside courses, and we do the load pages, okay? These functions that we just explained right now. And now we are using Beautiful Soup, which is the HTML parser in this case. And we are stating that this is HTML, and we want only this class, the class that contains the text that we have seen before, okay? Now, yeah, and we are going to separate the elements, the text content, based on the new lines. We are getting it in kind of lines, and we are removing the leading and the spaces at the very end of the text, okay? Now, yeah, if we run this code here, we are going to get the documents. And the documents are the page content. It is just going to take a while to load it, a few minutes maybe. But then it will contain every page, okay? And a list of pages, and every document is actually should be actually inside this list, as we will see in a second. Okay. It is going to take some minutes, so if you have any question right now, you can actually post them in the chat. If everything is okay, just give me a thumbs up to understand. Okay, sounds good. Yeah, it's now done. So let's, for example, look at the first page. So as you can see here, I added to the document itself. So yeah, after getting the text from each document, I added inside a document object, and this enables me to add metadata to the document, okay? So the metadata is something that describes the document itself. And now each document became some kind of a document object, which contains two things, metadata and page content. So page content is the text inside the page, and the metadata is actually the link here, because I added the link as the metadata, okay? So if we open this link here, we will be able to see it as an introduction, welcome to Hugging Face course, and so on. So as you can see, introduction, then /n/n, welcome to Hugging Face data, Hugging Face course, okay? So this is the first page that we wanted to actually check. Okay, let me just plug the charger for the laptop. Yeah. So now that we actually loaded all the data, let's check how many pages we have right now. We have 95 documents, okay? So now let's use our model. So we pulled, if you remember correctly, we actually downloaded the model from Llama. Now we can use it, okay? Oh, sorry about that. Sorry, give me 1 second. I just need to turn off notifications, okay? So do you see the screen now? You don't see, you see it? No? Okay, give me 1 second. Yeah.
Okay, thank you, AbdElRhman.
Okay, do you see the screen now?
Yeah.
Okay, sounds good. So, okay, that's good. So now, since we downloaded the model, we can use it directly, okay? And to use the model, we are going to use a chat Llama. So this is a class that we are going to use from Llama to be able to query the model itself, okay? And now, um, so now this is going to be a Llama 3.1 object, okay? Sounds good. Now I want to query the model itself. So I can do llm.invoke. What is data science, for example? Okay. Oh, says connection is refused. So let's just try to connect to Llama again. Maybe the connection had some problems. Okay. And then we are going to use it directly. Okay. Now that we pull the model again, let's try to. So it's telling me to try pulling it. Oh yeah. So I didn't download it after actually I run Llama again. So let's download it again. And now let's try. Oh, it says that the model is not there. Try to pull the model. I'm sure that I pulled it. So is it actually listening? Yes. Okay. Sometimes hallucinates a little bit. So let's just try to, yeah, try to download it again. Yeah, now cool. It's going to take a while. I hope I'm using my GPU. Yes, I'm using an A100, which is a very powerful GPU. And then you can get the answer directly. But now this is not a RAG. I'm just querying the model as if you are opening ChatGPT and querying it. This is a foundational model now that I'm querying directly, okay? So we want to convert this model or to use it, utilize it inside a RAG. And this is what we are going to use in the next step. So first things first, I'm going to download Hugging Face Hub so that I can actually use an embedding model. Okay. So if you remember correctly, we said that we need to find the similarities between the text and the documents. And to be able to do this, we want some embedding model that actually finds the similarities between them. So again, what is an embedding here? So embedding is some kind of a representation for the text because you cannot actually use the text directly inside inside the model. So you are going to convert it into numbers, okay? And those numbers are called the embeddings. Now, I'm going to convert both the query into the embedding or the numbers for the query, okay, the embedding vector for the query. And then I'm going to use what? I'm going also to do the documents. So document one, we have doc1, embedding doc2, doc3, doc4, and so on. And then I want to compare the query to each document, okay? And calculate the similarity. How the similarity is calculated, we usually use something called cosine similarity, okay? I'm not going to go through how this is done or how cosine similarity is actually calculated, but it calculates the similarity between text, okay? Now, can someone actually think with me a little bit why this approach might be costly? What might be the problem here if I have a lot of documents and I want to compare the query to the documents? You can write your answer in the chat as well. Where is the cost coming from here? Okay, so I think someone requested to speak, but I don't have Yusuf, can you grant access from your side? Okay, I'm not very sure actually. Till then, can you write the answer inside the chat? Okay, so maybe since there are no answers and I don't have the option to actually grant permission to the mic, I'm not the host. Maybe I'll go through it very fast. So the idea is that if you have, for example, 1,000 document and you want to compare the query to every document, then you are having 1,000 comparisons. This is very time consuming, okay? What we want to do uh, um, is a way that does this process faster, and this is called indexing, okay? So what does indexing do? There are a lot of things that indexing can do. It actually can do the pairwise comparisons that we have seen here, or it can do it much more efficiently by, for example, there are a lot of there are many types of indexes, but I'll just explain one of them, okay? So for example, if you have a lot of documents, then you group the documents that are similar together while you build the index. So now the 1,000 documents are clustered inside 4 clusters, for example. Okay. And now when you have a query, you are not going to compare it directly to every document here. You are going to compare it to something that is representative for this cluster. Okay, the cluster center, for example. And then you choose which cluster is actually much more similar to this document. And now you eliminate everything else. So for example, if cluster 4 is more similar, then you eliminate cluster 1, 2, and 3, and you compare the documents pairwise inside this cluster, for example, cluster 4. So now instead of using 1,000 points, you are using 1,000 over 4 pairwise comparisons. Okay, this is why indexing actually is very important, but it is a trade-off because it's less accurate now. You are not getting the exact answer. Maybe the answer is in cluster 3 and it wasn't very obvious. Okay, but now it is much faster, and this is why we use indexes. It makes the process much faster to retrieve the similar documents. Okay, this is a trade-off, and we at the end, if we have time, we are going to talk a little bit about it. Okay, but this is one of the margins of improvements. You can use many types of indexes, and you can use different index libraries, for example. But first things first, let's first do the embedding model. And the embedding model is the model that actually converts the text into its numerical representation. Okay. Now, is everything clear to now? Give me a thumbs up. A thumbs up if it is. Okay, sounds good. Now, we are going to use sentence transformer. Sentence transformer library, we are going to use an all many LM L6 v2. This is basically what is called SBERT. Okay, it is a variant of BERT. BERT is transformer-based architecture, but it is in the encoder side. GPT is a transformer-based architecture. It is in the decoder side. That just ignores this for now. And we are just going to use SBERT, sentence BERT, which was actually one of the very strong, models back in its day, a few years ago. But it is still good. Okay, it is still good, but it's not the best. What if you want a better model? There is actually a Hugging Face library a Hugging Face page that actually ranks the embedding models descendingly according to the performance on different benchmarks. You can choose from them, but I used one that is manageable in terms of memory and computational power. Okay, but you cannot use it. You cannot just use it out of the box. You need to do a wrapper for it, because our vector index, which is face is Facebook AI vector index. Okay. Now, if you remember what an index does, this is the part that actually, for example, clusters the documents together and minimizes the inference time when it comes to getting the most actually similar chunks of data. Okay, but now all what we have said is that we are going to compare it with the document, but this is not correct. We don't use the whole document. If the document is big, we need to chunk the document into different parts. Okay, for example, let's do it here. You have oh yeah, here, for example, this is the course that we have, right? Now we don't want to take the whole page as a document. Why is this not actually a good idea? Because each model has something that is called the context length. So the context length is the maximum number of tokens that the model actually can use. So if the context length is very large, for example, I give it the whole 2 pages and say that get the information from those whole 2 pages, then the model is not going to use except, for example, the first part of the page, and it will truncate the rest of the pages because of the separate context length, or I mean the fixed context length for the model. Okay, this is why we want to chunk it or divide it into different chunks that are actually more important or more similar to the query, and the model can use it to get the answers that we want, okay? So for example, if I say what is NLP, then I'm not interested to get this part, the rise of large language models. No, I'm just interested in this part, okay? In this chunk. And this is the idea about chunking, okay? So in a very simplified words, chunking actually helps us build a large language model that can get the most similar chunks from the documents, and this improves the model performance because it decreases the amount of tokens inside the prompt. Because what we are going to do next is that we are going to put this part inside a prompt for the model and ask it, what is large language model given this part of the text, okay? So if we give it too much text, then it is not going to use the rest of the text because it will truncate it. I mean, because of what? Because of the fixed context length. Okay, is this part clear? Let me know in the chat if you have any question, or if you want me to repeat it. Okay. So now now what? Now we want to chunk the data. There are many ways to chunk the data. This is by far one of the easiest ways, which is called recursive text splitter. What does it do? It chunks based on the characters. For example, you get 2,000 characters with 500 overlaps. Why do we do this? For example, if we said what is NLP, and this was 2,000 characters, okay? Now, there are parts of the text that are actually important to us, but will not be included inside this chunk. So we needed to get the context in the next chunk, because the next chunk will be going to be this, and the third chunk will be going to be this, for example, okay? So I need to give it part of the context from the previous chunk. So I'm going to add overlaps, and this is how actually it works. This, for example, would be, just for example, this would be my first chunk, okay? Now I'm going to put some overlap between the first chunk and the second chunk. Some overlap between the third chunk and the second chunk, okay? And so on. So there will always be some overlap between the chunks, the consecutive chunks, so that the chunk is not isolated from the context before it, okay? So it is a trade-off between how long our prompt is and the chunk overlap. For example, here I chose chunk overlap to be 500 characters just for explanation. Okay, but this is a tunable thing. Okay, and depends on your data and the structure of the data and so on. For example, I deduced that the paragraphs here are not very long, so I just used 2,000 characters. And I also have put some markdown separators so that they can eliminate it. And those are some part markdown separators, okay? The slash ends and so on. Now, if we run this, we will get first thing the splits, okay, the chunks. Here, it will take a few seconds. We can see here, and these are the splits. For example, this is the first split. It's in chapter 0, page 1. It says introduction and so on, and this is the first chunk. Now you will have the second chunk is once you are comfortable moving around in Collab. Let's see this part here. Here, as you can see, this is the overlap. So this part is actually overlapping between both, from ones till transformers and so on. Okay. This is a part for chunking. And now after chunking and making the splits, we are adding all those chunks inside the vector index so that it can cluster them and it can calculate the centers, and then we can actually compute the distance or the similarity between the query and the vector database. And now we are using LangChain vector store, and we are actually using it as a retriever, and we are giving it that we want to retrieve the most two similar chunks, okay? So here we are just going to retrieve the most two similar chunks. Now, we finished this part, okay? We finished indexing the data and building the embedding for the data, this part. We are going to get inside the retrieval and the generation, okay? This is the next part. So, any large language model needs a prompt, right? And for Llama 3 instruct models, they need a specific HTML tags, okay, as well inside the prompt. And this is why actually I used, for example, the begin of text, the start header ID, the end header ID, and so on, okay? And now, so the begin of text, start header ID, system, end header ID, it means that I'm adding a system message. So any large language model, it is preferably to use a system message with it. So a system message that gives it some personality. You are a helpful AI course instructor and mentor that answers the user question based on the context provided. So just to be clear here, you can use one of the prompts, there are actually kind of predefined prompts inside LangChain, but I'm using it here, a custom prompt, because I wanted to add the tags for Llama 3.1. You cannot, I believe you cannot do this with the predefined prompt, okay? So first you specify the system tag or the system message, and then the EOT ID means that you ended the system message, and then you start a new section, the user part. So the user part, you are giving it instruction what to do. Use the following pieces of retrieved context, and this is the most interesting part. This is what makes it a RAG, okay? A Retrieval-Augmented Generation. So you're telling it directly to use the context, only the context, okay? This part. Oh, sorry. This part, okay? This part is just empty for now. And then we are going to populate it with the context that is most similar to the question. We are going to see it in a second, okay? So we are telling it to use the retrieved context to answer the question. If the answer is not clear or not found inside the context, say, I don't know based on the provided context. Okay, this is the most important part. We don't want it to hallucinate. If you remove this part, it will hallucinate, okay? And you are telling it specifically, don't answer based on your own knowledge. Don't answer if the question is not related to the context, okay? Now, this is called the prompt template. So we are going to populate those missing parts, the input and the context, okay? We are giving it the question, which is the input, and the context here. And we are giving it, now we are ending the user part, and we are starting the assistant part. And we didn't end the assistant part because it didn't answer yet. So when it sees that the tag is actually still open, we didn't add the EOT ID after the assistant part, it means that we are waiting for its answer, okay? Now that we explained the prompt itself, we are going to add the string inside what we call a prompt template. A prompt template is one of the very convenient ways to actually add information inside strings using LangChain inside what we called a chain in LangChain, okay? So now we are going to construct a chain. But before we construct a chain, do you have any question? Any question? Oh, were there some? Oh, sorry. There were some questions in the chat, but it seems that I didn't see them because I needed to scroll down. Sorry about that. So there was a question about performance. What was it about? Is it the vector index or what? Tokens usage for every comparison? Yes. Oh, yeah. This was an answer. Okay. So yes. Why isn't it done as a function? Well, sorry, which part was that about? And yeah, if you could clarify those questions a little bit, and because I read it out of context right now. So sorry about that. The more documents, the longer querying stages. Yes, exactly. Need to check the embeddings against all the documents. Exactly. Computing power and latency. Exactly. And is indexing applied alphabetically? I don't believe it needs to be done like that. There are some methods to build indexes, but let's not go into them now. Okay. Um, yes, thank you for the comment about the battery. I noticed. Um, someone opened the mic. Um, yes, that was the host, I think. What is a system tag in the prompt part? Is this vital and had to be done or not? Okay. So again, it is encouraged by, for example, Llama, when you look at the documentation here for Llama 3 prompts, to use the system tags when you use instruct models. And the instruct models, in my opinion, might be, and as far as I know, might be better when dealing with question answering tasks. Okay. So now that we chose instruct models for question answering, then according to the documentation, you are encouraged or you should be using system tags. Okay. I hope I answered your question. Let me know if you need any further classification. And then there's another question. So if people could manage to break GPT, giving them illegal pieces of information, then this means that the line you added, if your answer is not provided in the context, say, I don't know, won't be enough. This means there is still a way for the LLM to hallucinate. There is always a way for the LLM to hallucinate. Even with the prompts that we gave, even with everything, it might also hallucinate. And this is why actually there are a huge margin of improvement in every stage that we talked about, in the retrieval, in the embedding, in the query, embedding, in the indexing. And I stress on the indexing because the indexing is a trade-off between efficiency and effective and accuracy. Okay, so if you want it to be faster, then you are losing some accuracy. And there is, for example, you can use more powerful models, and you can use. There are a lot of things. Let's talk about them at the end of the code. By the end of the session, we will talk about how we can improve it. Okay. Can you repeat the part for the prompt template? Yes, sure. So every LLM has its own instruct model, right? It depends. So some companies add instruct models for their LLMs, but it depends. You need to check the model itself, okay? And can I make that chunking for a local document? Like, yes, exactly. You can do the chunking for local documents like PDFs. Here we are using HTML. We are doing the chunking over an HTML, but you can use it on PDFs as well, for sure. You can use it even on videos. You can convert the videos in text and then chunk the text from the videos. So you can do a lot of things with chunking. You just divide the file into smaller pieces, okay? Now, so for the prompt again, you have a system message. This gives a personality for the chatbot. You have the task, which is a user message, and then you have the assistant message. And since the assistant message is not closed, I mean the tag doesn't have the EOT at the end. For example, here, if I add this here, it means that I'm not waiting for anything from the LLM. But now that I didn't add it, it means that I'm waiting for some tasks that the LLM is going to do. Okay. I hope this is clear now. So now let's build a chain. What is a chain? A chain means that it is a series of things that are used together to get the answer from the LLM. Let's simplify it a little bit. So now the first thing is that I'm getting the user query and the context. Okay. So I'm adding the retrieval, and after the retrieval, I'm going to add to do the format documents, which takes all the pages and concatenate them together inside the documents, okay? And then I'm going to add the input of the user, all of them in one stage. So here you are going to take the documents, add them inside the retrieval, and take the input for the model and retrieve the most similar chunks, okay? This is the first step. You retrieve the most similar chunks. Now, you are going to, as you can see here, this is a chain. So you are adding different parts to the chain, okay? So this is not an OR. This is a way for LangChain to understand that you are adding different parts to the chain itself, okay? So after getting the most similar, after getting the retrieval, you add the prompt, which is your question, okay? And you are going to get the most similar chunks, okay? After getting the most similar chunks, and you formatted it inside the prompt, as you can see here. So this is a prompt, okay? The prompt needs two things, input and context. And this is what we have here. So the input is the user question, and the context is the most similar parts, is the most similar parts to the user question. This is where you retrieve the most similar chunks. Then you add them inside the prompt, okay? Here, this prompt. You populate the question, for example, what is data science? And you add the context for this, okay? You don't add the context directly. You do it through the retrieval. It calculates it fetches the most similar chunks and it adds them inside the prompt. Now that you have the prompt with the most similar chunks, you give it to the LLM, and the LLM is going to give you the output. This is how a chain looks like from inside. Okay? Now we can use the LangChain library directly to create a stuff document chain, which gets the LLM and the prompt, and you create a retrieval chain, which takes the retrieval and the question answer chain here. So the question answer chain means what? Means that you are going to use a large language model with a prompt, okay? Now the prompt needs the context and it needs a question. So you are going to get this through the create retrieval chain. So it takes the retriever to get the most similar chunks of text to the prompt, and uh, uh, it takes the question answer chain so that can answer based on this context, okay? So this part is equivalent to this part, except that you can get the context directly also from this part, okay? So let's talk about this in a second, but now let's use it directly, okay? Any question? Can you recommend any source for multimodal? Right? Yeah, sure. Let's recommend some sources at the end. Okay, so now we are going to use it directly. Oh, give me 1 second. So we need to use directly this chains that we created, right? So I'm just going to use the functions that I implemented, and the LLM. Oh, I didn't run this part, right? Okay, so let's run it, and then now we have our rag chain and our rag chain string only. So this one only returns the output because it has an str output. Just for explanation, we are not going to use it. And we have a rag chain, and the rag chain actually is the main rags that we have. Okay, it 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 uh, uh, it has the ability to return both the answer and the rag. So let's try it. Rag chain dot invoke what are cookies, for example. Oh, okay. Oh yeah, it takes a query in this format. Okay. So let's do this. Yeah, it's called input not query. Sorry. Now, what do you expect the answer to be? We are expecting the answer to be, I don't know, right? And this is what we get. Answer is, I don't know based on the provided context. But now, as you can see, we get our two chunks from the retriever, but those two chunks are not really related to cookies. So the model itself, as a reasoner, doesn't use them, okay? So based on the provided context, it didn't find the answer, and then we are not going to use it. And you can just imagine that because we are telling it to get the two most similar answers, then it is going to get two answers here. It is not the most efficient way to do it. There are other parameters that we can tune, but just for the sake of this tutorial or this workshop, we are just taking the most similar context and the most similar two chunks, and then those two chunks are actually not related, so we are getting the answer I don't know. So this is how it looks like. It contains two things, the three things: the input, the context, and the answer. Okay, this is the context that we added in the prompt as well. So now I added this cell for just for unification of the output, just for formatting. So I'm not going through it. You can just take a look later. But let's ask it a few more questions, okay? So first question is, what is a transformer? And as you can see here, those are the two chunks that it actually acquired from chapter 1, page 3, and from chapter 1, page 4. They are talking about transformers and fine-tuning and so on. And then the answer, according to the context, a transformer is a type of model used for natural language processing. It's primarily composed of two blocks and so on, okay? Which is a good answer, in my opinion. Not the best, but it is a good answer. Now, what are the transformer components based on the provided context? The components of a transformer model include encoder, decoder, attention layers, and so on. Okay? And it gives the context as well and the links to the context. And this is what we wanted to do. Now we have built our first RAG, right? So now that we have our RAG, the second task is to understand. Yeah, and for the cookies, it said that I don't know based on the context, I don't know the answer. Okay. So now the next step is to improve our RAG a little bit, and for that we are going to need to evaluate it, right? But before evaluating, let me take your questions first. So if all clear, give me thumbs up. If you have any question, write it in the chat or unmute directly. Okay, sounds good. I don't find any questions in the chat right now. So, okay, there are two parts. There is something called questions and there is a chat. So I found something in the questions part. Hello, it seems that I joined late. Can someone please help brief me? I can keep up and benefit from the remainder of the session. So I'm going to send you some link by the end of the session that includes everything in details, right? As you can see here, so this workshop is not just a workshop, it's a tutorial, right? So I added everything in text so that you can actually go through it in details later, right? So there is another question: does this totally expose the data to the LLM? I think that was about the what was it about? About the foundational model. If you are using a foundational model, not a hosted model like the one that we are using here, then yes, your data might be exposed. It depends on the model provider and on the terms of use, right? So I hope I answered the two questions. Now, for the evaluation. So there are different ways to do the evaluation part, right? There are ways, just have some whiteboard. Okay, not on the other screen here. So there are ways to evaluate anything, right? any machine learning model, for example, you can give it some examples and true labels, and you can evaluate it based on that. So, for example, you can give it some questions: what are transformers? What is a transformer architecture? And so on. And then the true label can be some text that has the ground truth from the course, right? You can do this with a lot of questions and get a lot of true labels. Or you can use some benchmarking datasets. So benchmarking datasets are datasets that contains a lot of questions and answers, right? This is what a benchmarking dataset is. And there are a lot of benchmarking datasets, and you can evaluate your model based on that. But they might be very large. They might have some inconsistencies. They are basically used in research and industry settings, but they are not that straightforward, and they can take some time to run as well based on the size of the data and so on. But what if you want to evaluate your RAG on the data that you have right now, on the course data, for example? How do you do it? There are different ways to do them. There are, for example, what we call quality metrics that we can actually use to evaluate our model based on three things: the question, the answer, the context. What do we want to understand? We want to understand if the model, or we want to know if the model answer is actually based on the context, or is it hallucinating, or is it using some training data to actually get the answer. This is one thing. So we have the answer and we have the context. Then we want to understand if this is actually related to that, right? We want to understand if the answer is actually really answering the question, right? And we want to understand if the context is related to the question. Those are the three things that we want to understand. Is the answer based on the context? Is the context actually related to the question? Is the answer is actually answering the question? Okay. And we can see this using what we call LLM as a judge. There are different methods, but I choose this one. Okay. But there are different methods, and this is not the most accurate. It can be done for POCs and so on, but it has some direction in the research right now. So LLM as a judge actually use another LLM to evaluate your model. And there are two main libraries that I'm going to use here. There are TrueLens and Ragas. And those are two famous libraries. You will find in Ragas in many textbooks, and TrueLens in some, for example, courses. And this is actually what I wanted you to see. So now your model has a query, has a context, and has a response. And we want to evaluate if the context is relevant to the response, which is called context relevance. We want to evaluate the groundness, which means that it's a response only and solely based on the context. Okay, this is the groundness. This is why it's called grounded generation. Okay, and it's sometimes called the fairness. Okay, of the model. And we want to understand if the answer is relevant to if the response is relevant to the query or not, or we are just answering something else, right? It seems that there is some question. Yeah. So I don't find. Can you recommend source? Oh yeah, yeah. Okay. So yeah. For now, I don't find questions in the chat, but let's see by the end of the session. Those are the three metrics that we are going to calculate from TrueLens: the context relevance, the groundness, and the answer relevance. Okay. For now, let's first initialize the session for TrueLens, and now I'm going to speed this up a little bit because we only have 10 minutes remaining, so that we can finish and have 5 minutes for questions, right? So we need to specify the language models that we are going to use actually to evaluate our model, right? So I'm just using 3.18b, the one that I actually pulled earlier, and now I'm going to select the context based on the chain that I made earlier, which is a string only chain, right? That we have made earlier. And then I need three things, three metrics, okay? One of them is the groundness, one of them is the answer relevance, and the other is the context relevance, which is the one that we explained earlier, okay? And then what is next? Now we initialize the answers, the metrics. We need to add our chain and our metrics to a true chain. Okay, true chain is the chain that can calculate the performance metrics based on the LLM, the judge LLM here. Sorry, this is your LLM and the judge LLM here, which is Llama provider here, and the metrics that we have here. Okay, and just we give it some name and version and so on. And then we just run this. Now, what is remaining? What is remaining is that we need as many questions as possible from what? From our course, right? Based on our domain knowledge. So here I added just 7 questions or something like that, but we need as many questions as possible. And you can actually do this using another LLM, but this is something else, right? So, and the last thing is that you use the recording session, the true recorder here, to do something called the recorder session using TrueLens. Okay. Now, for every question that you have in the list, you are going to ask the chain to give you an answer to it, right? Sorry. And I'm just going to print the answer here, and then the model, the true recorder itself or the TrueLens itself will just record the answers and calculate the metrics as you go. Okay, this is how the session works. Okay, so inside this session, you get the answers, and then the model calculates the metrics based on them. Okay, as you can see, those are my questions, and those are the answers that I'm getting. And till I get all the answers, because it takes some time, there's something called the get leaderboard. So what does it do? The get leaderboard just gets you the calculated metrics based on the answers that you are getting here. Okay. And since I'm using a very powerful model, I'm getting, a very powerful GPU here, the A100, I'm getting the answers a little bit fast. But you can expect a huge delay if you are using a less powerful GPU, okay? So now you have answer relevance of 0.0 something, so it's very low. Context relevance of 0.5 and the groundness of 0.28. You might get different results based on how the model responds because it's a little bit probabilistic, right? But this is what I'm getting right now. And which means that there might be a huge improvement margin when it comes to answer relevance and also the context relevance and groundness. And we are going to talk about how to improve them in a second, okay? So now that we have that we used our actually leaderboard, that we used our evaluation for large, for true error or true chain. Here, now we can actually check another library called Ragas, but Ragas is a little bit different. It can do different tasks. And here I chose to give it the question and the answer that I have based on my domain knowledge, for example, from the course. So for example, I know that the course did this, talked about this. So I added it as a ground truth. And I have the questions as well. So what are transformers? What are transformer components? What is an encoder? And then I have the ground truth answers for them. And then I can run Ragas to actually get how good my model is, okay? but based now on ground truth answers. So this is just how Ragas works, right? So I'm not going to dive deeper into this, but it takes some time. Ragas is computing heavy here, so it takes some time to calculate them. Although they are just 3 questions, right? But 3 questions using faithfulness. Sorry, it's faithfulness. I think I called it fairness. It's faithfulness. Faithfulness is actually groundness. Okay. Um, and context recall is context relevance, and factual correctness is answer relevance. Okay, it's very similar to that. I mean, there might be some difference in the calculation of the metrics itself inside the libraries, but they are very similar in this context. And now you are getting very different results. You are going to get very different results using Ragas when compared actually to TrueLens. Okay, and this is actually reasonable as well. So maybe until it actually continues to answer my to get actually the results, we can talk a little bit about the how to improve the model itself. Okay, there are different things that you can do to improve the model. So, for example, you have something called embedding fine-tuning. Now we understand that the answer relevance is not very good, and the context relevance is not very good. Context relevance is not very good, which means that the context might not be very relevant to the question. And this might be because, actually, it's not very bad as well. So it's 0.75. But yeah, you can improve it using something called embedding fine-tuning, which means that you get, for example, there are actually many ways to do it, but the idea is that you fine-tune the embeddings based on the context relevance. So, for example, you give it some examples, and it tries to get the answers from the course page, and then you fine-tune your embedding based on the results that you are getting and how relevant they are actually to the question. And this is done on your data. So now the embeddings are fine-tuned to your data to improve the retrieval, right? To improve the retrieval part, to improve the relevance of the context to the question. Okay, this is one of the things that you can do. But what else can be done? For example, how to improve the context that is actually being retrieved. You can use something called query rewriting, for example. Query rewriting means that I have a query, but the user query is not very similar to what we have in the course, and it's usually very short, right? So it might not be very descriptive. So you kind of use a new large language model and you ask it to get an answer, and it will hallucinate. For example, what is a transformer architecture? It will hallucinate a little bit, but it will give you a nice paragraph. Okay, you take this paragraph and you calculate the similarity between it and the text chunks. Actually, in the literature, it was proven that this improves the model retrieval a little bit. For example, according to large language models, a deep dive textbook, embedding fine tuning improves from 5 to 10%. Okay, and query rewriting also improves it. And also, for example, we have something called query to doc. Query to doc means that you use a third large language model to convert your query into a large document, and this document you calculate the embedding between it and the text chunks. And this actually was proven to improve it by 15% according to the query to doc paper. Okay. So those things actually improves the retrieval part. But what about the generation part? There are many ways to improve the generation as well. There are things that are called, for example, you can use a more powerful model. For example, you can use something called query re-ranking. So after the retrieval part, you rank sorry, not query, context re-ranking. You rank the context. Okay, but yeah, let's not get into this. I'll just send you some very useful, papers and resources at the end, and textbooks, the names of them, and then you'll find them actually very, very useful for this. So yeah, last thing is that we can see that the library actually gives us 0.77, 0.72, and 0.6. This is not bad, right? But now we have also very few questions. We have only 3 questions, and we have 3 contexts and so on, three ground truths and so on. If we increase this a little bit, we might get more reasonable results, right? But now that we understand how to evaluate it, now we understand which part can be improved. We need to improve the faithfulness. We need to improve the context recall, and we need to improve the factual correctness. And every one of them is actually related to one part, right? As I mentioned earlier, one of them is related to the retrieval, one of them is related to the generation, the other is related to the indexing. Every one of them has a lot of improvements that can be done. And as I said before, because I only had 1.5 hours, I'm going to share the resources with you, and you can ask me any question if you want, right? So for now, do you have any question? No? No questions till now. So give me a thumbs up if everything is actually clear. Okay, sounds good. So I'll also be available if you want to ask me any question on LinkedIn, for example. You'll find my profile attached to if you pressed on the profile here in the event, you will find my LinkedIn profile, and then you can ask me any question, or you can send me a direct message, for example, and I'll answer you directly, okay? For now, I'm going to send you the link to the Kaggle notebook, and since I know that you have other sessions that you would like to attend as well, I shouldn't be taking too much time from you, okay? But here is the link to the Kaggle notebook. You can use it on Kaggle, but Kaggle has a lot of difficulties when it comes to the libraries that I'm using. So it is more encouraged to actually clone it and add it to Colab, for example, or something like that, okay? Or use it locally. Yeah, that's it for today. And thank you so much for attending. And yeah, maybe see you tomorrow on the event. Thank you so much. I think I can actually stay a little bit more, 5 minutes, if you have any question. But yeah, it's okay.
ماركت اللي هو قدرت له اللي هو اسمه هنا ماركت.
Okay, thank you, AbdElRhman, for such a clear and beginner-friendly guide into RAG systems. We'll take a short break now. See you soon for the next session.
Thank you.